Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at inequalities. So inequalities are like equations, but instead of having an equal sign, they have one of these inequality signs. So make sure you're aware that pointing to the right means greater than, this means less than. So here this says x plus 3 is greater than or equal to 7. This says x plus 3 over 4 is less than x. So how do we solve inequalities? Well, an issue here is that this won't have just one solution. If x plus 3 is greater than or equal to 7, x can be anything that's greater than or equal to 4. If I substitute any number for x greater than or equal to 4, it will give me a true statement. X equals 4 is a solution because it makes this statement true. X equals 5 is a solution because it makes this statement true. X equals 207 is a solution because it makes this true. You can probably work out pretty quickly there are infinitely many solutions here. Any number, literally any number greater than or equal to 4 is a solution here. So because there's not just one solution, sometimes we like to display visually the solutions. So here we have our number line that you would be familiar with. So what are the solutions for x? So it's any number greater than or equal to 4. So we have our arrow pointing to the numbers that are more than 4, and here we use in a shaded circle. So you shade in the circle when you're including that value. So if it's a greater than or equal to or less than or equal to, you don't shade in the circle if it's greater than or less than. Shaded in means it includes the value directly underneath. X equals 4 is a solution here because 7 is greater than or equal to 7. So this is the set of all of those infinitely many solutions. So you might have already guessed that the way we solve inequalities is pretty much the same as solving equations. There's just one difference that I'll go through on the next slide. But if we have an equation like this, we're going to do exactly the same as we would if it were an equation, if this were an equal sign. So what we would do if this were an equal sign, well, we'd get rid of the fraction first, and we'd end up with x plus 3 is less than 4x. We would have times each side by 4. What you do to one side, you must do the other. Timesing by 4 gets rid of the fraction. So we know for equations, when you have pronumeral on both sides, you subtract the one with the lowest coefficient. This is a 1x. So I'm going to subtract x from both sides, just as I would for an equation. So I'm left with 3 is less than 4x minus x is 3x. So now I'm going to undo timesing by 3 by dividing by 3. So 3 divided by 3 is 1. And of course, 3x divided by 3 is just x. So I get 1 is less than x. It might be a bit confusing to write it that way. Note, 1 is less than x is the same as saying that x is greater than 1. So to display this on the number line, I go to 1. Now I'm going to use an open circle because I'm not including this value. 1 is actually not a solution here, because if I substitute x for 1, I get 4 over 4. 1 is less than 1. That's not true. 1 is not less than 1. 1 equals 1. So that's why this is not a solution and not included. I want all the numbers greater than 1. So I'm going to again draw an arrow that points to all the numbers greater than 1. So remember, shaded circle if it includes that value, open circle if it doesn't. All right. There we are, we've solved our first inequalities. Now let's look at the exception that I was talking about. So I said on the previous slide, you solve inequalities the same way as you would equations. It turns out there's just one small exception to that, and that is if you are multiplying or dividing each side of the inequality by a negative number, you must reverse the inequality. You only reverse the inequality when you're multiplying or dividing each side by a negative. So why is that? Well, when you multiply or divide something by a negative, you change its sign, and it turns out that changes the inequality. So you know, for example, that 4 is greater than 3. Okay, yep, absolutely mind-blowing. But if I change the sign of each of these numbers to make it a -4 and a -3, well, the inequality reverses. -4 isn't greater than -3, it's actually less than. See, to go from here to here, all I did was times or divide each side by -1. That's why we need to reverse the inequality. Whenever you're multiplying or dividing each side of an inequality by a negative, you must reverse the direction of the inequality. Okay, let's look at this example. 24 minus 5x is greater than 9. So we're going to solve this like an equation. We are going to subtract 24 from both sides. Because, of course, add and subtract 24 undo each other. So I'm going to be left with -5x is greater than 9 minus 24 is -15. But I want to get x by itself. The way I need to do that is by dividing each side by -5. What you do to one side, you must do to the other. Here I am dividing each side, left and right, by a negative. So I must reverse the inequality. -5x divide -5 is x. Reverse the inequality. -15 divide -5 is 3. So x is less than 3 is the final answer. We only reverse the inequality when dividing or multiplying each side by a negative. All right, let's try this one here. So we're going to first get rid of the fraction. We're undoing dividing 2 by timesing each side by 2. So I'm going to be left with 5 minus x is less than or equal to 7 times 2. Now I'm going to get rid of the 5 by subtracting it. So I'm going to be left with -x is less than or equal to 9. This negative belongs to the x, it stays there. So I don't want to know about -x, I want x by itself. So the way you get rid of this negative, because it's essentially a -1 coefficient, is you times or divide each side by -1. So if I divide each side by -1, once again, I am dividing each side by a negative. So what I must do is I must reverse the inequality, change its direction. So I get x is greater than or equal to -9. All right, let's now look at a harder example. So this here is called a nested inequality. Read this as x minus 5 over 2 is between and including -3 and 3. Let's go ahead and solve this inequality. So what I can do is multiply each side by 2. So I get -6 is less than or equal to, so multiplying the fraction by 2, denominator goes away. Less than or equal to 6, and then I can just add 5 to both sides. So -1 is less than or equal to x, which is less than or equal to, so adding 5 to both sides. This tells me x is between and including -1 and 11. So that means that any number between and including -1 and 11, if substituted for x, would give me a true statement here. So how would you graph this on the number line? Well, let's just set up a number line. We'll just put 0 here, 1 here. So what we have here are all of these values in between 1 and 11. No point writing in all of them. So we want to include 1. We want to include 11. Okay, I'm doing shaded circles here because I'm including each of those values. So it's any values between them, we just go like that. There are still infinitely many solutions to the original inequality, but here they are bounded between 1 and 11 and don't go on forever. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.